Hey everyone, thank you so much for sticking with us. I know we had a few technical difficulties getting out of the gate there, but the most important thing is that we've arrived. So thank you and welcome. I know many of you have registered for today's event. You're excited to be here. You planned on it. And without further ado, we'll kick things off. Again, we're starting here with episode 1 of the Amazon EMR Insider Series. I am by no means personally an EMR expert, but that is why I have the lovely two gentlemen here joining me today. They will do a better job introducing themselves. My name is Nick Walsh. I'm a developer advocate here at AWS. But let's move on down the aisle. Who are all of you wonderful people here today?
I'll take it over. My name is Ray Hassan. I'm a senior manager for analytics. My team specializes in everything big data, and EMR is one of them.
Kunal Agarwal, co-founder and CEO of Unravel Data, and we do cost, performance, and migration management for AWS. Super excited to partner here with Roy and team.
Awesome. So I wore my favorite shirt that relates to EMR today. I don't know if we can all see that, but we got, big data here. And I figured we could use that as sort of a jumping off point, Again, many folks that came here for this content today are pretty familiar with EMR, but I'll pass it over to both of you really quickly. What sets of problems involving big data does EMR solve? What are the basic use cases? I know, Roy, you're going to dive deep on that, but can we give folks an overview, maybe people tuning in that maybe haven't used EMR before?
Yeah, no, sounds good. I think one of the best way to do it, I'm going to share a slide here, just easier to kind of anchor that. But basically, what EMR is, if you don't already know what it is, right? Think of it as a fully managed cluster system that allows you to launch any of our big data frameworks. The most popular ones are Apache Spark, Hadoop, Hive, Presto, even HBase. We have 19 different applications that you can run. We have customers also run machine learning algorithms and training on top of EMR. It's a great platform that automates and simplifies all of the cluster management aspects of it. The thing that really awesome about it is that you don't really have to think about all the software versions and as open source upgrades to different versions of different components. Like, we just capture all those things and make it available for you. It's all low cost, right? If you look at our pricing structure, you pay for the compute, you pay for separate for storage, a little bit for EMR, but there's no licensing cost, there's no support things that you have to deal with, and it's pretty easy to use. And we talked to some examples later on today, but as you play around with EMR, you'll see how easy it is to get started with that platform.
So Roy, looks like Amazon EMR is one of the places where you can run big data on the cloud. As companies are thinking about moving their workloads from on-premise to the cloud, why EMR?
Yeah, no, that's a great question, right? We get that question asked all the time. So, of course, I have a slide for that as well, but we'll kind of talk through that too. In reality, kind of when we look at this, when we talk to all of our customers, there's a lot of different reasons why you'd want to move from a self-managed, whether that's running on-premise, on maybe EC2 on AWS, but you're responsible for doing all the work, for doing all the heavy lifting. It's tedious, it's expensive. You got to have engineers on call. I can tell you this. Nobody wants to be on call. Nobody wants to be called at 3 o'clock in the morning to go fix a problem. But the three kind of big areas where we see customers sort of focus on those challenges are being over provisioned, right? But also underutilized. Kind of interesting, right? But as you build out these clusters, you're looking at your maximum or your peak utilization, and you buy hardware and you configure your environment for that peak. But on average, you rarely meet that peak. And we talk to customers, they're usually between 50 and 60% utilized at any time during the day. And only in some specific times they burst to max utilization for like an hour, maybe even less than that. So we see a lot of money being spent, a lot of operational complexity being added to the platform just to be able to meet those spikes. And it's very, very expensive. The other one, and I mentioned this before, but the open source software community like moves so fast, and there's new versions on regular basis, new patches, security fixes, all those things. How do you stay, current with all those things? How do you stay on top of that? And when we talk to customers, that's one of the biggest challenges they tell us that they're having when running on a self-managed environment is that they're starting to fall behind. It's so hard for them to go upgrade that cluster when there's so many workloads running on it, and be able to kind of stay with the open source community. And the biggest bottleneck is security, right? If you miss some security patches in your OS or your applications, that can open you up to a lot of pain. And that's something that, customers and companies can't sleep at night because of that. So that's a big challenge. And then the other last one, the big one that we have is missed SLAs. Right? And this can mean a lot of different things, whether it's interactive queries, it's reports, ETL jobs. There's a lot of dependencies between these jobs, and missing SLA on one little thing can cause repercussions down the line. And this could be attributed to resource contention, right? Maybe somebody's running some crazy queries for their data science workload, but it's clobbering the resources, and the report that you need to run for your CEO every day is getting delayed because of that, right? There's also seasonality aspects to this, right? Many customers, financial services, insurances, they may need to run, large data processing workloads at the top of the month or at the top of the quarter, right? When that happens, what are you going to do? You're going to call up and order hardware, a few weeks before and rack it up and then use it? No, you already spend the money. It's really not necessary just for this burst of usage. So those are big things that customers are really having a challenge with, and they're a big impact to their bottom line, right? And if we think about this, right, the way for us to reduce the total cost of ownership and really free the customer for using more and be able to actually innovate much faster is through a number of different levers. And we'll talk through some of those today, of how to do that, right? And it's, finding the right instance type, right? Maybe you just bought a bunch of hardware in the past and that's just kind of outdated now. You really want the latest and greatest. You want to get the power and performance that maybe AMD gives you or the AWS Graviton CPUs give you, right? That's very difficult. But on a cloud, on AWS, we make it super easy for you. And there's other ways, right? Because you're not always 100% utilized, you want to be able to use auto scaling, scale your cluster up and down, only pay for the resources you need. So there's a bunch of different levers that we can talk about today that allows you to kind of reduce that total cost of ownership.
Yeah, one of the biggest things, you hinted towards it, but like when we're talking about things like, EMR, the ability to constantly be switching your underlying infrastructure, your servers, to the latest and greatest, most cost-effective servers is something that is so difficult to do if you are running an on-premises operation, right? Like the actual work required to do that, and nonetheless the cost is like insurmountable. And to be able to just flip a config setting to the latest EC2 instances that back that is a really powerful experience.
Yeah, absolutely. We'll talk about that in the sort of the auto scaling section of this conversation. But our flexibility there is really, really great. So you can actually auto scale up and down based on different instance types, right? So as new come out, more cost-effective instances are available, you can simply add them to your cluster automatically, so you can get that benefit right out of the box, which is super awesome. So the other thing I wanted to kind of talk about too is when we talk about the benefits, right? There's a bunch of challenges and we talk about saving some money, but how do we actually implement this? How do we help our customers do this? And one way that we do this is through this migration program. You can go to the link below or send us an email if you have any more questions, but we're actually making 2 resources available. The first one is around what we call the EMR Migration Guide, and it's a 140 some page long guide that takes you to all the best practices, all the tools and tricks and things that we've learned around migrating on-premise Hadoop environments to the cloud. So you can learn a lot. But we actually also offer a free migration assessment workshop that we can actually come to you, sit with your engineers. We'll actually bring Unravel data with us to help us have a much more data-driven approach to understanding your workloads and deconstructing your environment. So we can actually give you a much needed sort of TCO analysis and help you build the business case to actually migrate to the cloud, and then bring professional services or SI partners to actually execute that. So, I'm kind of jumping through these slides, but I really want to capture, now that you understand kind of the benefits and the program that we have to help you, when we talk to customers about migration or modernization, right? There's really 3 approaches that we take, right? And then to Kunal's point, like why AWS, why EMR, right? These three approaches, I think, make it or kind of solidify that, right? So the first one is the lift and shift. I think that's the typical one that you always see. It's less time consuming or requires less effort. It's pretty easy. Kind of take what you have on premise and let's just duplicate it on EMR. If you look at our applications, we match them all very closely. So it's very easy for you to kind of lift what you have and shift. And why would you do it? Maybe you're under tight deadlines to close down your data center, or maybe you're under cost pressures and you just need to move to the cloud so you can get the benefits of cloud infrastructure, auto scaling up and down of resources. Lift and shift is easy to do. The re-architect one is actually an interesting one, and we're seeing more and more customers kind of choose this path. It gives you the kind of the maximum amount of capabilities in the sense that you're thinking about the future state architecture. You're not just simply thinking about solving my problems today, but where do I want to be, right? So maybe I got my Spark workloads. I want to move those Spark workloads to EMR. Maybe I have some old Hive data warehouse workloads. Maybe it's best for me to move those to Redshift, for example, right? We can spend time with you guys to understand like what the workloads are and how do we architect it correctly for future state architecture that will serve you well into the future. And then the last approach is I call this net new, but it's really about sort of saying, okay, I'm going to leave what I have on-prem right now. I'm not in a particular rush, but I'm gonna try EMR out. I'm gonna take a brand new workload. Maybe it's some marketing analysis that I got to do, or some financial calculations I need to do, or even machine learning training. I can just launch that on EMR as a net new workload, move my data over, and then do that. And as over time, I can add more and more workloads. So those are kind of the three key migration approaches that our customers follow. But to be successful at picking that right migration approach, you really need to understand your workloads. You really got to be able to dive deep into it, understand the different workloads, the different users that you have using your system. What do their utilization look like? Are there some bursty workloads, less bursty workloads, right? Are you overutilized or underutilized? What part of the day is that happening, right? So that's a lot of work. And then honestly, that's kind of the hard part, right? Because I'm sure you don't have 4 workloads like I do. You probably have hundreds or even thousands of workloads. So this becomes hard to do. So with that in kind of in mind, right? I want to pass it on to Kunal and really kind of ask him that question. Like, Kunal, you've been doing this with a lot of customers over the years. You have a lot of experience. You built an amazing tool around this. Can you kind of tell us what it is that you can do here to help us understand the workload so we can actually pick the right strategy?
Roy, you are absolutely correct. Going to a AWS environment without knowing what you are going to actually run there is like going and buying a laptop without knowing what you're going to be actually using that laptop for. If it's web browsing versus gaming, because for gaming you definitely need a lot more memory, for example, right? So what Unravel provides is a way to get the benefits of everything that you just mentioned and help you migrate in the fastest way possible using intelligence, right? So the 4 key points that I want to showcase today is, number 1, understand how cloud and AWS in particular is very beneficial for you, right? Which workloads should be moving to AWS EMR? How would you map this current environment that you have to the right cloud architecture? What should that topology look like? Which instance types should you get? Should you use auto scaling? Should you use transient clusters? And clearly understand the cost and the effort before you migrate, right? Rather than just getting a ballpark estimate, actually have a data-driven approach to go and figure all of these different kinds of pieces out. So with that, I want to show you a couple of screens here. What you're looking at here is a discovery analysis where Unravel is connected to your current environment, and it's able to instantly populate everything that you need to know about that environment, right? So what are we looking at here? is all the details about the current environment, what services are running, what hosts am I running, give me all the infrastructure and OS and service level information. And then here I have all the app information, right? What jobs am I running? Are they all Spark, or am I running some MapReduce, and am I running some Presto? And which users are actually running these apps, data pipelines on this environment, right? Is it one user, or is it hundreds of different users? And really get a breakdown of all of those different users as well. Because not all users are made equal, right? Some may be consuming more resources, some may be doing more ad hoc jobs versus scheduled data pipelines, for example. And it's really important to break down this usage by all this variety of different use cases that you may have. And you may also think about different types of departments that may be running, and maybe it's a shared multi-tenant environment, right? All of this information, if you have to try understanding manually, would take you a couple of weeks. About 8 to 10 weeks is what we've seen on average for all of our different prospects without using Unravel. And as soon as you get this, it kind of provides you a MRI of your entire stack, right? Helps you glean inside everything. And once you have this info, you can start to think about all the points, Roy, that you mentioned about, right? Which is, hey, what benefits do I get from moving to AWS EMR? So for example, right here, I can see, one of the points you mentioned was a lot of these on-prem clusters are over-allocated. In this case, this on-prem cluster is definitely over-allocated. I see my average usage being about 25% on CPU and about 30% on memory. This is a great reason to move to the cloud, right? Where you don't have to pay for perceived capacity, but you're always paying for just the amount that you're always using. Another reason could be, this particular users, their applications are always failing because there's contention of resources in that multi-tenant environment. Another amazing case for moving to the cloud. Or you may just have seasonality. Some applications don't require the resources that they do on certain days of the week, whereas on other days of the week, they require a lot more. So you can use the auto scaling capabilities, again, to get what you need and don't have to compromise reliability and performance with cost, right? So once you have this view, what Unravel can then help you understand is how do you do the mapping to the AWS EMR environment? And depending on the strategies that you choose, in this case, we're going with the lift and shift. If you lift and shift, which is I want to do a one-on-one on-prem to the cloud migration and not change all the underlying infrastructure and want to have that same capacity there, then Unravel will map every host and all the services and all the applications that you're running to the appropriate AWS environment, and also give you a cost for running that. So in this case, it's saying, hey, it's going to cost you about $475 per hour to run this on Amazon. But we just saw previously that I'm not actually using all the capacity that I have on premise, so why would I do that? So now Unravel can help you understand, hey, based on usage, not on capacity, what should I be migrating to? And then you get all the host details on, in this case, it's a pretty memory intensive workload. So we've gone in and chosen a particular type of instance that's best suited for that. It's also gone in and sized like, hey, you only need 16 cores. You don't need 8 cores. You don't need 32 core machines, for example. 16 would do just fine for the type of workloads that you're running. And if you do that, you're spending $140. So you see the drastic reduction that you can get where you were spending about $750 per hour when you move to the cloud AWS, then you actually save a cost just by sizing your environment based on usage rather than capacity. Now, to think about it a little bit further, what if you don't want to move everybody? And you think about, hey, let's go find out which users are best suited for the cloud or which type of application that I'm running is best suited for the cloud. You may think about only migrating your Spark workloads to Amazon EMR. Or you might think about saying, hey, let's only move the marketing department to Amazon EMR. Unravel can also help you figure out the kind of fine-grained visibility that you need and get that particular subset analysis. So in this case, I'm looking at the marketing data out here, and I'm seeing how much they're using the cluster on all these given days of the week and time of the day. and then mapping that particular tenant or use case to AWS EMR. So in this case, I can run the marketing workloads, all of those applications with about $100, guaranteeing all the SLAs are met, right? So I'm also optimizing here for performance and reliability. And I need about 14 instances to do so. And all the other parameters around what kind of object storage I need, which type of machines I need, everything Unravel calculates for you automatically, right?
So
now, to further improve the cost and performance characteristics of this, we can see here, right? Certain days of the week, we're not using the cluster a whole lot, whereas the other days we're using it a lot. We can also enable auto scaling with all these EMR functionality that we have to further improve the efficiency and reduce the cost that we have in the cluster. So you're seeing over here how many VMs need to run on any given day of the week and different times of that day. And if you enable auto scaling, you know what? We need a base VM line of maybe 6 or 7 VMs, and then auto scale it on Sunday to about 14 VMs when we really use the cluster a lot. And if you enable that, you can further save 25%. And now your cost of running the marketing workload with auto scaling enabled becomes about $77. So you see how you can have a very data-driven discussion with all the people inside your team around why you should be moving, and if you do decide to move, what's the best candidate for moving there, and how can you further save costs. Roy, while you mentioned all the benefits of EMR and how you migrate there, are there any cost-saving features that EMR has when you're actually already on EMR?
Yep, no, that's a great question, right, Kunal? And by the way, I love that demo. I mean, the challenges that we talked about, and then you just come out and you show exactly where to find that information. And that's the kind of stuff that our customers are looking for, and it's been super helpful in the past as well. But once you kind of understand these workloads,
jumping in here real quick, one call out in chat, but also one for you, Roy. If you switch your displays, I think it's showing you the notes or the presenter screen there. But yeah, no big deal. If you hit swap displays in the top there on the top left, I think that should fix it. Yeah, you're good now. And
awesome.
While I'm butting into this conversation, I figured this would be a great segue into letting everyone know, again, this is a live show. This is not pre-recorded. Please get any questions you may have in chat. I'm happy to sort of pull those into the mix here. I apologize again for interrupting the wonderful conversation. I'll pass it right back to you. But again, I'm watching chat. If you're here, sign into your Twitch account, get those in, and I'll bring those up, and we'll talk with Kunal and Roy about them. But go ahead, Roy. Sorry, I rudely interrupted.
Awesome. No problem at all. Yeah, definitely ask us questions. Love to make this more interactive. But no, this is a great question from Kunal, and I think the bottom line here is that there's a lot of things that you can do to improve your cost overall. The three kind of main features I wanted to call out here in particular is something that we've been kind of working on over the last I'd say year and a half, and it really stems from a couple things. The first one is we really want to give our users the best possible experience, save them money, give them the best performance. But the other one is our customers kind of coming back to us and saying, look, EMR is awesome. You give us a lot of levers, a lot of knobs, a lot of ways to tune and configure. But what we really want is you AWS to just kind of put the best practices or the best possible configuration, already bake them in, right? Yes, I know how to configure it, but you know what? It'll be really awesome if you just do it for us. And that's really what we've done here. So if you look at, if we're talking about this, so we've released something we called Amazon EMR Runtime for Apache Spark. And what that is taking kind of the vanilla Spark environment and creating a API compatible performance or optimization layer that we bolt on to the Spark engine. Now you can run Spark as is, no runtime at all, and still get the same benefit, get the standard benefits. But if you really want to get performance and all the work that our performance optimization team has been building, you can launch EMR with the runtime, and you're going to get a ton of performance benefits right out of the box without doing anything. So forget about benchmarking, forget about Spark memory and container and executor tuning and all that kind of stuff. We just do it all for you, right? We built all that stuff in, and we continuously adding more and more functionality to make it easy. So think about taking the workload that you had on premise on managed Apache Spark, taking that workload and moving that code directly to EMR. Out of the gate, you're going to already get performance benefits, right? And because it's running faster, you can actually downscale or even terminate that cluster sooner and saving you money, right? So we're seeing actually 2.6x faster performance with Spark on EMR with this runtime compared to the open source Apache Spark. There's other solutions out there. They may have their own, optimizations, but when we tested ours, we really saw a big advantage there. And then also reducing costs, right? We'll talk about this as well, but there's different modes of running your clusters. You can run in a persistent mode, right, where cluster is up 24/7. You scale it up, scale it down based on requirements, or maybe you opt for a transient model where the workload requires you to spin up a cluster, run the workload, complete it, and then terminate the cluster. So if you can run it faster, complete it quicker, you can actually save money on that. One example that I want to call out, Drop, is a startup company that basically allows their customers to collect reward points when they shop in different stores that they typically shop on. So if you go to Amazon.com or Uber, as you shop there, you get points. So they actually did, and there's a blog post, you can see the link below, where they go into more details. But this is a really cool kind of benchmarking assessment that they've done that shows the differences between the EMR runtime on EMR version 5.29 compared to 5.27 before we introduced the runtime improvements. So you can see on the smaller workloads, which is the green boxes, there's a huge performance improvement. On the bigger workloads, much more data, there's still significant performance improvement. Maybe not as big, but still pretty significant. So this is a pretty great example, and we're seeing more and more customers leveraging this. So again, you can simply launch EMR. You don't have to do anything. And out of the gate, you get these performance benefits and cost savings. The other thing I wanted to talk about, something that I'm actually really excited about, it took a little while to get done, but the team has done a phenomenal job at putting this together, but it's something called managed scaling. EMR already has auto scaling. And auto scaling basically is a way for you to configure how you want your cluster to scale up and down based on any number of parameters, right? Memory, CPU, queue depth, et cetera, et cetera. But it sort of puts you in a driver's seat to determine what parameters and what thresholds do you need in order to scale up and down. What we really wanted to do is simplify the whole model for our users and give them something that they don't really have to make a lot of decisions around, and we just do all the heavy lifting for them. So we created managed scaling. And managed scaling, all it asks you to do is to tell us what's the minimum size of the cluster and what's the maximum size of this cluster that you want, right? So you're not over scaling up too much and maybe costing you a little bit more money. So you kind of set those thresholds. And then behind the scenes, we evaluate a number of different metrics in under 10 seconds. So the response time is very, very fast. And are able to kind of auto scale the cluster up and down as close to the workload as possible, right? So this is actually a great example when data scientists, data analysts, data engineers are using the cluster, but the cluster may be managed by an IT infrastructure team, right? Maybe by a different team. So for that user to say, hey, I need more capacity because I got a lot of data to process today, they have to go to the IT team, and that's just not a good process. So with this environment, they can just simply process more data, right? And the cluster will just automatically scale without requiring any configuration or any help from anybody else. So this is super exciting. I love this. Customers have started using this a lot, and we're seeing a ton of benefits from this. And we're kind of capturing a 60% cost savings on this, just because our auto scaling is much closer, much more aligned to the workload. We can scale the cluster up and down much faster to meet the demand of the workload. So that's cool. If you haven't seen it yet, definitely check it out. The other cool thing about this feature that I don't really think other solutions out there provide, and this kind of leads us into spot fleets. So I think, Nick, you mentioned earlier about the ability to kind of pick and choose the right instance types that you want to use in your cluster. So in EMR, we have a number of different or three different ways to look at capacity or hardware. The first one is kind of the master nodes, right? You probably don't want to touch that too much. That may run an on-demand capacity, so it's stable. Everything is there. Then there's two other modes, right? There's the core instances, and the core instances are basically compute plus storage for HDFS. And then you have the task instances that are compute but without the storage. So when we look at auto scaling using managed scaling, we can actually design it in a way that you only auto scale the task instances, for example, because downscaling core instances with HDFS will take longer. And because we have to shuffle data around, it'll take longer. It's a little bit more problematic potentially. So it's not something you ultimately want. You can definitely scale them up and scale them down. It'll just take a little longer. But task instances, think of them as the extra horsepower that you throw on your cluster to give you that boost of CPU and memory. And those we can scale them up and down. And the beauty here is that we can actually leverage EC2 spot, and those are basically EC2 capacity that is less popular at that time of day that you're running, and can be given to you at a high discount, right? Typically 70, 80, even 90% discount. Now you can define your instance fleets, your collection of instances, in a way that says, I want to have a few on-demand instances, and I want to have a few different types of spot, an M5, an R5, maybe something else. So now behind the scenes, what EMR can do for you can monitor the spot market and the capacity available in the spot market, and intelligently switch between spot instances so you're not being impacted in case a spot instance gets taken away from you because of increased demand or an increased cost, right? So that spot capacity awareness of EMR is a big differentiator that we see for EMRs, because now it can look at what's out there. It can be very smart about which instances to choose from your fleet.
Yeah.
So that's kind of the three big features that EMR gives you to both improve performance, improve the stability of the platform, simplify your management aspect of it as well, but also reduce cost.
Yeah, and Roy,
Now,
quickly, if we go back to the spot instances slide, I did a show centered around things like cost savings and improving compute capacity through spot instances with Chad Schmutzer, one of the developer advocates dedicated to spot here at AWS. And one of the cool things that he showed me, and correct me if I misinterpreted this, but essentially, when you're scaling out and have this ability to mix spot and on-demand, you said that you could have mixed instance types. And a lot of the times folks are trying to spend a lot of time right-sizing, and with tools like Unravel, it helps them understand the optimal instances they can deploy to for their workloads, make it as cost-effective as possible, let's say. But when you throw spot into the mix, you have such a broader pool of instance types you can use, because the discount is often so deep that you can even run your workload faster than it would have at a significantly lower cost than on-demand. And that's a really common pattern to use for these scale-up scenarios or scale-out scenarios, let's say, where you sort of use on-demand up to your minimum or reserved instances up to your minimum, and then you use spot to handle sort of that fluctuation above steady state.
Yeah, absolutely. I mean, I like to think about it as, going to Vegas and renting a Ferrari for the weekend just to kind of drive around extra fast, right? Because, it's not the thing you do every day, but when you need that power, you need the performance, it's very easy to kind of throw that capacity at it. And when we look at the examples before, right, the seasonality that Kunal was talking about, right? If you need, if you have the end of the quarter comes in and there's a bunch of heavy computation that needs to run, you can throw all these spot instances at the job, auto scale it, and then get that done very fast. And we've seen customers basically reducing time from multiple days to complete jobs down to hours at a significant cost reduction, just because they're able to use spot and auto scale the capacity on their EMR clusters. So yeah, you're absolutely right. It's a great flexibility that the platform provides.
To extend your analogy of the going to Vegas and getting the Ferrari, if I were to take that a step further to really paint what that looks like, it's like booking a reservation for an economy car, or like, hey, I'll take whatever's on the lot, and it's like a mystery box, and you happen to get a Ferrari for less than the cost of the economy vehicle, right? I think that would probably be the most apt way to compare how spot instances work.
That's a much better analogy.
Well, it's teamwork. They come together to form the analogy. So
as long as we're going to Vegas and driving Ferraris,
Yep. That's the next time. I think we should have an event around that. The last thing I wanted to call out here is that, so I talked about these big features, right? The Spark runtime, great performance, reduce time the job completes, the managed scaling, also the instance fleets. The last thing is I wanted to kind of capture all that in one sort of message that kind of bring it all together. Why Amazon EMR is the most cost-effective data platform, right? And the biggest things I kind of called out here, but I'll mention them again. We bill per second, right? So when I talked about when EMR runtime, if your job runs faster, well, if we bill you by the hour, does it really make a difference? It doesn't really make a difference. But because we bill you by the second, it makes a huge difference, right? If your job took 45 minutes, now it's taking 46 or it's taking 47, right? Those are all cost savings that over time really, really add up. From a compute perspective, we have a number of different cost discounts that we can provide. RIs, those are reserved instances that you can purchase up front and get a big discount on. Savings plan, right? It's another great way to say, hey, this is the instance family I want to use. I want to get a big discount on them. You can get it through the savings plan program. Spot, we talked about. So we're talking about putting these things together. The compute aspect of it, we can save you a ton of money. S3 versus HDFS, I think most people kind of know what this is about. But when you store data on HDFS on local hard drives in your cluster, you're paying for those hard drives. You're paying for the durability and high availability of HDFS, which does a 3x replication across the cluster. So now you're paying for that extra hardware and hard drive that you have to put on there. Just move the data to S3. You get all the availability, durability, everything out of the box with S3 at a much lower cost. And you'll see later on too, like we talk about, sort of S3 data tiering, right? If it's hot, keep it in S3 standard. If it's getting warmer or colder even, we can move it to a less expensive or more cost-effective storage tiers like infrequent access or one zone in S3. Still very accessible through EMR, but you're spending less money on storage. Managed resize, runtime, we talked about capacity aware spot scaling. And then the last thing, EMR gives you all these features for free. Like if you look at some of the competitors out there, for managed scaling, it's a little bit extra. For some of the performance improvements on Spark, well, you get some things, but if you want the really hot, the really cool stuff, well, now you're gonna have to pay a little bit extra, right? We give it to you all out of the box. I put some acronyms in it like LF, that's Lake Formation. That's our centralized data governance and fine-grained access control service. It's free of charge. It works with EMR, so you get that out of the box. Hoodie, it's Apache Hoodie. It's a great way for you to actually create data sets in your data lake and have it manage it for you without really having to do anything. You get that for free, right? So all these things just come for free. Which is a great reason why EMR is the most popular target for migration. So that's kind of like a good summary of where things are going. What I want to do is I want to kind of pass that on to Kunal to give us an update on kind of like what can Unravel do here? Like I gave you a bunch of features, but now that your cluster is running on EMR, you have workloads, you want to leverage some of these tools. You really need visibility. You need the best way to look into what's happening and the insights to sort of take that visibility and tell you, okay, based on this, we're going to make some recommendations. So Kunal, I'm going to pass it on to you and let's kind of see what Unravel can do for us here.
Thank you, Roy. So ultimately, there is so many different ways to go and save cost, right? And what Unravel is a performance and cost optimization solution designed around these big data workloads. So on one hand, it helps you understand which applications and workloads you can actually use those cost optimization features for. Like, hey, which apps are best suited for Spot, right? You want to make sure that you're getting the cost benefits, but you're also making sure that you don't have interruptions using Spot fleets, for example. And the other hand is there are so many other ways to further reduce cost that could be just in the application itself, right? Bad code is bad code. And how do you go and improve that? Or how do you go and get the right number of instances for running your app or the entire workload on this cluster? A lot of different configuration settings can drastically improve performance and reduce cost of a lot of these different jobs running on this environment, whether that's a big data pipeline that you're running on Airflow or a simple BI query that you're running on Presto. And lastly, really understanding, hey, if I want to take advantage of data tiering, how do I get an understanding of which tables are being used and which ones are not being used? So then I can tier them appropriately, right? And again, balance out reliability with cost. So that is exactly what Unravel does. So once it's connected to your environment, and you can get Unravel either through the marketplace or through a SaaS version, what you're looking at here is a view of cost and usage for all of the EMR clusters that I have connected. So I have about 50 clusters that I analyzed over the last month in June. And what I see here is, first of all, a nice breakdown of all the costs, right? So I defined some tags in my purpose for BI workloads, some ETL workloads, for example. And I can see here that my ETL purpose clusters that I spun about 29 of them took an average of about $800 and in total costed me $22,000 last month, right? And what Unravel is doing is constantly hunting and prompting, hey, what are the ways in which you can save money and improve performance? So all I have to do is click on this Insights button instead of going into monitoring tools and trying to triangulate all this information. And Unravel's analyzing all of the workloads that are running on that environment right now. And then it's saying, hey, for those purpose workloads that you were running, you could be using Spot for that, because Unravel's analyzed and said that the jobs that are running on that workload are rather short running. So you're not going to be interrupting those workloads a whole lot. And that's perfect for running Spot. And if you run Spot, you can save $508 out of that $800 that you're running on average, which totals up to about $15,000 or so. That's massive, massive savings right off the bat, right? As Roy was explaining using Spot.
That's
the other
great
piece.
insight. Yeah, sorry to cut you off, Kunal. I think that's a really great insight, right? Because we hear a lot from customers like, hey, you tell us use Spot. Spot's great, but when do I use it, right? This is a perfect example of when to use it.
Exactly. And again, to make that decision, you need to have that visibility. You need to understand what workloads you're running and how those workloads are requiring the resources, how long they run, et cetera, et cetera. So instead of doing all that work manually, come into Insights, and if it is a potential cost saving, Unravel will point that out for you. The other one that we're seeing here is actually changing the instance type itself. So it's saying that, you're running R5 4 extra large. All of you who are viewing this are potentially using Amazon. So there's lots of different EC2 choices. How do you go and figure out which EC2 choice is best for you? And Unravel, again, analyzes all those workloads, and it's saying, you know what? You don't need 4x extra large. You can get that same performance by actually using 2 extra large, and doing that change is going to help you save another $10,000 monthly, right? Up to that much. And the way that we got this, I want to illustrate one example here. So of course, I have all the details of all the jobs that ran on all these different clusters. So I'm going to jump inside them to further drill down on, how did that insight even come up? So this cluster was running these Spark apps. And what Unravel is doing is going and analyzing everything that's happening over here for how do we make them faster? How do we make them cheaper? How do you make them more reliable? So in this case, all of the performance and cost reasons of the app is placed in one screen. But instead of you having to go and figure things out, Unravel connects the dots, and then it presents to you in the form of insights. So it's saying, hey, Unravel has 4 insights. You click on that, and then it starts actually telling you that, hey, your current memory is sized at 3 gigs. You really don't use more than a gig, so you should put it at 800 MB. The CPU that you currently have allocated for this particular app is also not being used 50% of the time, right? So it has all this information that it's going in and drilling in on. Like, for example, looking at memory out here, I'm never using more than 800 MB on a particular phase of my execution. So why am I spending all that money when I could be running it with the same performance, for example, with just different instance types in this case, or just using fewer instances in other cases, or using Spot in another case, right? So don't have to do a whole lot. It comes to you. It could be in the form of alerts, which could be emailed, which could be Slacked, which could be put in your favorite messaging tool. And all you need to do is just enjoy all the ways in which it can actually save you that money. So going back here, I actually applied those changes in the month of July and ran a couple of these workloads in July as well. And now let's go and see what the cost of the ETL environment or the purpose of these clusters look like. So ETL, if you remember, was costing me about $800 a run, is now costing me about $300 a run. And I've run this about 14 times because it's still mid-month. But my total cost so far is about $4,000. So that's a drastic reduction than what we currently had. And you see all the different clusters now are actually using Spot. And they're doing so without interrupting or making the workloads that are running on that unreliable. Now, I want to show you a couple more examples where just tuning applications as well can drastically help you reduce the cost as well as guarantee performance of these applications as well. So again, Unravel's on the hunt. In this case, we saw some ETL jobs. Now you think about some BI queries or some interactive queries or some AI and machine learning queries that you may be running on Spark, for example. And it's going in and figuring out all of the ways in which we can help you over here. So you see all of these applications are either already sent to your email, or you can come into Unravel and view it right here. And opening them up, just as we did previously, will help you understand what are these different insights or recommendations or automatic fixes that Unravel is helping me out with. In this case, this app was running at about 55 minutes. Maybe that was too slow for me. Or it was very expensive, and I'm coming in with that lens to go and figure out how do I save dollars on this particular application. So when I open it up, Unravel will help me understand, hey, if you don't want to do anything, just go and make these changes that Unravel is recommending, and it will save you a lot of money or reduce the time. But then for us curious people who want to go and understand what's really happening out here, it's gone in and analyzed like as an expert would, and it's saying, hey, there are some recommendations in how you can speed up the performance of this particular job, or there are certain changes that you can go in and put in to go and improve how much this job costs. So in this case, it's talking about some executors, some instance types, some cores, all of these different configuration settings that drastically affect the performance and cost of these types of applications, right? Similarly, you can look at different data warehousing workloads or BI workloads where you may have certain inefficiencies in the application code itself. In this case, let's go and jump inside a application that's running Hive on Tez, for example. That's similar use for if you're used to using Presto, where it's saying again, hey, there are ways in which you can improve application efficiency, but in this case, it's not all the setting parameters for the containers or right sizing the instances. But in this case, the problem for this app today is, in how it's fetching column stats and it's not updating those pieces. So that is affecting the performance of your applications. Or your query could further improve performance if you're using filtering conditions like putting in a where clause, or you have parallelism improvement possibilities within this particular application. So it really depends on what the problem is, and out of the hundreds of possible ways in which you can improve performance and cost, Unravel will bubble that up for you and say, hey, these are the 2 things for you to focus on. And if you do this, then it will make your application and your overall cluster just much, much better.
And I think that was a great summary. And I hate to be the bearer of bad news here, especially as someone who's much like the audience members, just enjoying listening along. But we do have another stream at the top of the hour, which is in just under a minute. So I wanted to give us enough time to sort of gracefully close out. I know there was some more stuff that you did want to show, Kunal, and I apologize. But we've got containers from the couch coming up right after this, the top of the hour. But for folks that are interested in learning a little bit more about Unravel, where can they go to learn about that?
Absolutely. So you should give all of this a shot for yourself. There is a free trial, and you can learn more at unraveldata.com/EMR. And you can always find us on the Amazon Marketplace.
Awesome. So in recap, again, today we covered in episode 1 of the EMR Insider Series a little bit about how to optimize your costs with using EMR, a little bit in the beginning around that migration to Amazon EMR, some of the latest and greatest features. Roy covered that. And then Kunal showed us a lot around how we can use Unravel, one of the AWS APN partner tools, to be able to actually save money on that migration, but to additionally save cost with this observability tool and automated recommendations around how to cut those costs and optimize your cluster configuration going forward. Awesome.
Thank Roy. It was a lot of fun. Thank you so much for having me.
I'll see you all in Vegas with the the Spot Instance Ferrari rental dealership. But without further ado, again, containers from the couch coming up in just a moment. Thank you again to everyone who tuned in. We'll be back next month with another episode. So see you around and have a great rest of your day, everyone. Thanks.
Yep.